Hello, and welcome to lesson 7.1.4. Today we're going to be looking at scaled relationships. And just to kind of remind ourselves a little bit about what we already know, I want you to look at the figure of the two F's. There's an original and a drawing 2. And I want you to write at least one thing you notice and one thing you wonder about this drawing. Okay, now that you've written down what you notice and what you wonder, here's some things that maybe you did notice or wonder. I noticed that drawing 2 is larger than the original. I also noticed that in order to get this length here, which is 2, to the drawing number 2, it goes from 2 to 4. So that tells me you have to take this length, multiply it by 2, and you get the 4. On this side, I noticed that it's already 4 on the original. And on the drawing 2, it's 8. So I also noticed that you have to take this original length of 4 and multiply it by 2 to get the drawing 2 length of 8. And finally, I looked at the last line. This one was 1, and this one's 2. So again, you have to take the original length of 1 and multiply it by 2 to get drawing 2. And then that makes me realize, gosh, I'm doing the same thing to every side length on the original. I'm multiplying it by 2 to get drawing 2. So that tells me the scale factor is 2, because I remembered that scale factor is the number you multiply the original by to get the scaled copy. So these are scaled copies with a scale factor of 2. Now let's move on to our objectives. Our goal today is this, that we're going to be able to use corresponding distances and corresponding angles to tell whether one figure is a scaled copy of another. So we're doing lesson 7.14, which is scaled relationships. So if we're looking here, can we tell if GF or DC on these two figures, can we tell the lengths of them? We can't, because they're actually slanted. They're not on grid lines, right? So even though this looks like it goes through 1, 2, 3, 4 squares, we can't say that it's a length of 4 because it's not on actual grid lines. So when we have figures like this, what we can use are, well, let's see, can you tell the lengths of DB and HF or FH? We can, because they're on the grid line, right? So we know FH is 1, 2, 3, 4, 5, 6 grid lines across. So it's a length of 6. And DB is 1, 2, 3, 4. Are they corresponding parts? Yes, they are. They're the same length on both figures, right? So they're in the same place. They're like a match. So these are corresponding parts, even if they're not side lengths. Can we tell the lengths of AC and FG, or EG, sorry, GE, EG? Yes, we can. Because even though they're not, like this one's on a grid line, it's exactly on the grid line. So we know it starts up here and it goes 1, 2, 3, 4, 5, 6, 7, 8. It's 9 lengths across. It's 9 or up and down. Now over here, the AC is not actually on a grid line, but we do know it starts at this grid line and ends at this one. So even though it's not on one of these up and down lines, I can still tell that it's 1, 2, 3, 4, 5, 6 squares up and down. So this has a length of 6. This has a length of 9. Are they corresponding parts? Yes, they are. Again, they're matching. They're the same part of each figure. So they are corresponding parts. That means we can use these two sets of corresponding parts to see if this second figure is a scale copy of the original ABCD. Notice I have highlighted both red are the corresponding parts, and then the blues are the corresponding parts. So we're going to use this chart to help us out, or this table to help us out to see if EFGH is a scale copy of ABCD. And notice what I've done for ABCD, so for this figure, I went ahead and added the two lengths that we found on the figure, right? So AC right here we found was 6, so I put that in, and BD was 4, so I put that in. And I did the same exact thing for EFGH. So EG we knew was 9, and FH was 6. So if I want to find out if these are a scale copy, I have to figure out, did I multiply the original lengths by the same thing to get the copy? So to do that, we're going to have to figure out in the first one, what do we multiply AC by to get EG? So in my mind, I'm thinking, what times 6 equals 9? And I don't know that off the top of my head. So I know if I want to find out 6 times what is 9, I can do 9 divided by 6, and that will tell me this missing piece. So I wrote it in two ways. You can write 9 divided by 6 like this, which actually means the same thing as this fraction 9/6, because fractions are division, okay? Now, you can use a calculator and just do 9 divided by 6. If you do that, you're going to get 1.5, or 1 5/10. Or if you wanted to just reduce this fraction, you can do that too. So I know that 9/6 equals, well, let's see, I can make one whole if I have 9 pieces and 6 make one whole. So that's 1. And then I'd have 3 of these pieces left over. So 1 3/6. And I know 3/6 is a half. So 9/6 is 1 1/2, which is good because guess what? 1.5, remember 0.5 means 1/2. So 1.5 or 1 5/10 is the same as 1 1/2. So again, I'm just going to point this out. To find the scale factor, meaning what number do we multiply these by to get here, all we have to really do is take the copy length and divide it by the original. So we found the scale factor in this case is 1.5 because we do 6 times 1.5. All right, now we're going to check out the bottom, the other corresponding parts. So now I'm going to think what times BD is FH. So what times 4 is 6? And again, remember, if we want to figure this out, we take the copy side and divide it by 4. So we get 6/4, 6 divided by 4, the same thing. And again, you can put it in your calculator and get 1.5 or 6/4. If you reduce that and put it into lowest terms, we can get 1 2/4, which is also 1 1/2. So the scale factor here is 1.5. So the last step is we have to decide, is this a scale copy of this? So is EFGH a scale copy of ABCD? Well, did we multiply both of the original lengths by the same number to get EFGH? Yes, we did. So that means it is a scale copy, and the scale factor is 1 1/2 or 1.5. And I'm noticing that if the scale factor is 1.5, it actually means that this got bigger. It's 1 1/2 times the size of the original. Now, you try. Here's our same figure that we just had. right? I want you, as a cool down today, to figure out, is this IJKL? Is this a scaled copy of EFGH? I even gave you a little table here to help you out. So once you finish this, you're done with your cool down, and I'll see you later. All right.